This is the recording for the homework for Unit 7 on electricity and electric circuits. So here is what you're supposed to do. These are the learning objectives. Then here, of course, is to access the homework quiz. Make sure that you have the work.problem 90-page Word doc available. These are my videos for the work.problems from the textbook. Then here I did something extra, so I did this mini lectures. I think it's almost an hour long. This one, by the way, is really long because I really get into detail on these solving these problems here, but this one here is relatively long. However, at some point, notice that for this mini lecture on circuits, that you will come across something like combinations of resistors and series and parallel and Kirchhoff's rules. Don't do these because that's not part of your class. That's for Physics 124. And then, of course, you have to read through a couple chapters in how everything works. And this one here is a recording for the physics educational technology, which are great simulations that are free on the internet, and so I made a recording there, and I'd like you to look at that one as well. And then there's the mechanical universe, and this time around there are 3 to watch these here. All right, let's get going with the homework quiz. All right, homework quiz. So of course the first one here, just enter yes for everything here as you're doing this. So you're working on the worked-out problems, you're watching the mechanical universe, you read the chapters and so on. The second one, you're familiar with that by now, the exercise question that you're gonna post and your answer to that. The third one here, physics content and objectives, read through these here, and I believe all of these here apply, so you may want to check them all. You will find all of these in the book and the objectives that I have lined out. This one, of course, here goes with the worked out problems, which are in that Word doc, as well as posted on YouTube in my video, or a couple of videos perhaps, because they're pretty long. And obviously this here makes sense. Force F equals 5. Well, that's probably newtons. So I'm going to choose that one. Charge Q 2.8 times 10 to the negative 6. That's probably coulombs right there. But still, make sure that you look at these problems and work through them. Watch my videos for them and figure them out. And then, of course, force, again, Coulomb force, gravitational force, they all should take on newtons. Charge, again, is Coulomb. Electric current here, that's probably amps. Resistance, that's probably ohms, and so on. So kind of like almost a giveaway here, but still look at those problems. All right, electrostatics and circuits. So let's see, individual voltages add to the total voltage in a purely series part of a circuit. Individual currents all equal each other in a purely series part of a circuit. So when you played with these here, or when you watched what I'm doing with these circuits here, you will find that individual resistances add to the total resistance in the purely series part of a circuit. This here must be in my recorded lecture circuits posted on YouTube. So look at these here, and I chose these resistances, and they're added to 250 amps, yielding 0.04 amps when using a 10-volt battery in the purely series part of the circuit. Individual voltages all equal each other in a purely parallel part of a circuit. Individual currents add to the total current, again parallel. Individual resistance add as reciprocals to yield the equivalent resistance, invert again, in a parallel circuit. And then I chose these resistance, which yield an equivalent resistance of this much. So if you add 1 over 30 plus 1 over 50 plus 1 over 60 plus 1 over 90, and then you come up with something in the neighborhood of 0.08 something. You invert it again, you come up with an equivalent resistance of 12.3 ohms. So that again is a purely parallel circuit. While developing how resistance add in parallel, at some point, oh, I made a mistake apparently in my recording. I corrected it a few seconds later. And let's see what I was saying here. Apparently I tried to divide current by voltage, which on second thought would have worked and so on, but read through this one. And then of course work through Bloomfield's, read this chapter here and then check which ones apply. There's a lot of them actually that apply in this one here. Top of my head, I know it had Lenz's law in it. There should be something about conductors in there, alternating currents, Ohm's law. Quite a bit are in here. Let's see. And then the last question, I believe this is the last question here. No, I'm sorry. This is the PHET's question. So again, I have a video there. I also encourage you to play with the simulations, and here I'm just going to give the answers away because you would have to watch the video or play with the simulations anyway for these numbers here to make sense. So I think I'm just going to give them away. The first one here is in parallel. The next one here is 3.77 amps. The next one is 16 ohms. Next one is 16 ohms, but differently rounded. Wow, there are a lot here. So this one here is the resistor. Ooh, the resistors catch on fire right there. So again, watch that video actually. When there's too much current going through them. This one here, I believe from now on they're actually in the correct order. So I have like answers H, I, J, K, L, M, N, O, P, Q, R. But again, please watch that video. Okay, now finally here, I believe is the last question about mechanical inverse. So in this case here, yeah, you have to watch 3 videos. And just like usual, this one here is the first quote. In this case, I actually don't have quotes. Electricity is a 19th century science, and it's really easy to attach names of physicists to them. So that's what I did this time around. So the first one here is Van Marum. Then let's see. You would have to look for the next 4, and then let's see what it says. The next 5, and again, are from the electric battery, so from the first one. So that means that once the lemon, let's see, correct order, lemon produces a voltage. There are 2 lemons in here. A lemon produces a voltage. Where'd it go? Yep, it's this one here. That should be quote number 6. And then the others are in between here. And then quote number 11 is Charles Wheatstone. There he is. So this is the first quote here from Marum. So to say, I mean, that's when he brings them up, and then the others are in there. They could be in, these 4 here could be in reverse order, a little bit maybe. Then the 6th one here, I believe, is lemon produces. And oh yeah, I think these others here in between are then in the same video, and then this one is the 11th, and then the others are after 11, and I believe they're also kind of in reverse order. But of course, please watch the Mechanical Universe videos, and that's the recording for the Unit 7 homework.